You've built the laser tag sets, played a few games with the stock code, and now it's time to understand how the code works to modify the gameplay or add in your own little cheats, if you want to. There are 3 laser tag stock codes that are in the CrunchLabs IDE. They are the light and reload codes, and one detail that makes them different from the other bots is that they aren't really different. Let me explain. The laser tag has the exact same core code throughout all stock codes to keep the fundamental gameplay the same. The other difference is what is added in the additional codes. Most secondary stock codes stick to the software hacks apart from the IR remote hack found in several. But laser tag is only hardware hacks. They just added some new hardware for some enhanced game dynamics, like seeing your LED colors light up, knowing when you've been shot by seeing it go red, and if you want to play by teams, you can see which colored team you are on. As you can imagine, the core game mechanics of the laser tag are simple. You're playing laser tag. Pull the trigger to emit an IR signal that if another laser tag receives in, it then determines whether or not you're on the same team if you have teams enabled. And if you are not, you've been hit, which then calls the mark hit function, which then turns your goggles dark and then disables your trigger from being able to send a signal for a certain specified amount of time, which you could change in the code, and we'll see how you can do that. So let's go ahead and jump right into the regular stock code. So this is the setup for the game, the pins that you need to add in to be able to get the trigger to send information, as well as to obviously trigger the trigger to send it. All these little pins are pretty straightforward. Just get them set up as they are originally specified with the build. Nothing new to change there. We'll see some changes a little later on when we do add some more components. It's a little bit complicated. You can set up the teams. That's the green little section on your bar. And this is just the pins that are identified to it, also known as the analog pins, A1, A2, A3. So far, we use a lot of these libraries already, so we're not going to cover them much more. You create your servo. That's what turns the goggles, and it is a continuous servo, by the way. I thought I was positional the first time. Now we get down to some of the timing of the game mechanics. This is what you can change if you want to, for example, change how long it stays dark. That's what, if you want to look here, you can see the hit timeout. That's to when you get hit, how long it needs to time out. The cooldown for the trigger is so that way you don't spam it. So currently it's set at 500 milliseconds, which is half a second. So if you drop that a little bit less, that means you can hit your trigger a little bit more. If you want to be sniper mode, where you only get one shot, say every 1 second, you can increase that to 1000, which is 1 second. This is the speed of the servos to get them to move for the goggles. Wouldn't mess with these unless you just kind of want to change the dynamic of how the goggles move, which you can by any means. The interesting thing in this set is you don't ever see 90, which 90 is telling it to stop. What you will see later on in the code is it actually attaches the servo, which then calls the servo to do movement, and then it'll actually detach the servo. We'll take a look at that a little bit later on. This section here just sets up some of the variables that we'll be using later on. We're not going to cover them a lot in detail, but essentially it's kind of the timing for debouncing, how often you can spam the trigger, as well as the trigger state, whether or not the button's working, some of the timing aspects. This is to know how long you have left for the timeout, currently 10 seconds, to wait until you can start playing the game again. This section here are the commands for whether or not when you're playing the teams, the send signal and the receiving signal. In the void setup, we get the servo in the right position. So when it gets turned on and moves to the open position, so you can see that's what it's just doing, is getting into that ready position, and then sets up all of the inputs and outputs so that way it can receive in whether or not what team you're on, as well as being able to pull the trigger. And once you have LEDs built in, you can see that. The digital read is reading from the analog pits to see which one you have it plugged into to select a team, and then it updates which team number you are on, which, as you can see right at the bottom here, it will then tell what signals are sent. So let's take a quick look at that. This is the signals that are sent for each team. So if you are team 1, you are sending this signal and are able to receive these two. And then you can see throughout the rest of it for team 2 and team 3 which signals they are. There is a potential to add more teams. This is where you could do that. Up top, you can add, say, a team 4. And then down at the bottom, you have team 4. And then you just have to find a couple different signals that you can send. Use the IR remote and kind of grab some of those signals that aren't used. Since it is the same protocol, they should work. And at the bottom, we just set up the serial begin and tell the receiver to start looking for information. For the laser tag, they really simplified the loop to be calling a bunch of commands. And in this one, you'll see a bunch of nested commands, meaning you'll call one command, and in that first command, that call function, you'll actually see another function being called, and it will actually keep calling other functions until it's completed its whole process. So let's take a couple closer looks at how it chases through all the different function calls once you initiate that first one. For the void loop, there is a timing aspect of how the gamer's played, and we'll see that a little bit later. And then it just checks to see how you want to handle the trigger if it's been pressed, which it will check in that function, and then if you've received it. So essentially in the loop, it's trying to know if you've sent a signal or if you're receiving a signal. That's all it's looking for in this loop. For the handle trigger in this little section, it's just going to ask a couple questions at the top, whether it's the button has been released. The read trigger button calls another function to see if it's been sent out, and then it checks just kind of a timing aspect to make sure you're not spamming it. Remember up at top, we have that 500 milliseconds before it can send another signal. So it's checking for that, and then also what state the button currently is in. And if it is false, meaning it hasn't been pressed, it then sends an IR pulse, or it sends out the signal that you have. So when you get this send IR pulse, which jumps down here, all it's going to do is see what pulse it should send. The S command variable up top, that's all it's going to send is this S command using this little method. To get to the read trigger button, you have to go down all the way to the bottom. At first, it's just looking to see if the trigger has been pressed. And if it has been pressed, it goes through this whole check to see if the timing wise it can be pressed, and then what signal to be sent back to then continue through the rest of the process. Now it's checking the other side of the code, whether or not when you've been hit, what to do. The handle reception checks to see what to decode if there is a signal being sent, and then it runs through the check player hit right down here, checks to see what data was received. So these are the two other signals that we've seen up top. So again, if you want to add a fourth team, you'll have to update this section of code to look for the third team that is your opponent or your enemy. Then it does the timeout to be able to check to see whether or not you've surpassed a certain amount of time. And then if that's the case, mark hit jumps down to this function right here. This is where all the magic happens to disable you from being able to play the game with the goggles turning dark and also disabling your gun. Now keep in mind, this is the first one. This is the original one, so it doesn't have anything extra other than just turning the goggles dark. So you have this mark hit function, and it checks to see what time it is, because there's a timing aspect that is different than delay. Delay will actually stop the code from running until the time is set up, and we don't want to do that. We want to be able to continue to see where things are at and also make some changes, particularly when we add the next layer of hardware. But that complicates things for the servo movement because it's moving a certain amount of time. And that's where we see, instead of having it stop at a time, it just hits the mechanical stops or the pinch points where they run into each other at the end, and it should stop it. But we have seen some issues with it not working the right way. This is where you can modify the code so that way it will actually stop the server from trying to move when you set it to that 90, which is the stop, or basically the middle ground. 0 is max one way and 180 is max the other way, clockwise or counterclockwise, and 90 is the middle ground where it doesn't move the servo, it doesn't give it a speed to move to. We see that the servo is set up, and as you can see, it's a little bit odd because we're attaching the servo in this section. It's different than the IR turret where the servos are initiated at the beginning and then we don't ever detach them or stop them from getting information, where you will see that in the laser tag. So we attach it, get the pin, wait for information. This is where you can change the time of it to make it go slower. That would be changing the speed, so that way it slowly moves, because right now that's all it is it's telling the speed for you to move. And right now it's moving in the direction to close. We hit this while loop. So let's take a look at what this is asking for. So while the millis, and this is checking what the time is currently in the Arduino. So the combination of these two, the millis minus the timeout start time, while it is less than that hit timeout, currently 10 seconds, you continue to run through this section of code right here. Once it hits a certain time frame, so it's not the full 10 seconds, but a little bit less, it then starts moving the servo back the other way. Once it hits that final time out of this while loop, the while loop will kick out and actually detaches the servo, meaning it won't be able to interact with it. And that's what gets it to stop again. But this whole 10 seconds, this servo was actually trying to move to this hit position, but the mechanical stop should stop it. But that ultimately is the original gameplay. Once you add the light code and the reload code, you're adding some extra components, particularly the LED bar. So let's go ahead and take a look at just those components in the next sections of code. The key piece that you need to understand is what information you might need to change for your game. Oddly enough, the upgraded version of the laser tag has a wire harness, almost like a bar, that blocks out from pin 5 that you see here from the receive pin all the way to 9. So these two are connected with the signal and the servo, the harness that runs through it, and then there's a block that helps you make sure that they are put into the right place. The problem is now 7 and 6 as well as 8 are all blocked. You can't use them. So you have to change these pin numbers and connect them to something else. For example, I switched mine to pin 2. The other thing is I'm using the LED bars from the Sand Garden, and those actually have 8 LEDs. So you can increase that to how many LEDs that you have on your specific LED bar, or even if it's just a strip. When you're doing the reload, again, you have to change that one. I used 10 or 11. I didn't actually set up the buzzer on this one, but you can set up the buzzer with 11. So you might have to finagle which inputs you're using to be able to tell where they're at, where you're plugging them into in this section. That's the key part. The big one is adding the library, Adafruit NeoPixel library. Now this is one of the type of libraries you can use for LEDs. There's LED Fast, I believe. There's a couple different ones. They specifically use this one, so you need to understand the parameters that this specific library uses. Particularly, you can see it right here, the NeoPixel strip. This is what you're going to see throughout the rest of the code. You have the LED count, which is the macro that we used above, and the LED pin. And here's some setup. Don't know exactly what those are about, but it's the setup needed. Particularly, it looks like for the color and what kind of ranges that you can use for the colors. The other thing that you could see from a variable is the reload time. Currently takes 1 full second for the reload to start and to end. So you can modify that if you would like. In this section here, we definitely have a few new variables that we haven't seen before. They have a couple fun game mechanics that now you can add infinite ammo. So that way you can unlimited ammo so you don't have to reload. The max ammo is to help understand how many LED bars later on, and you'll see how we use that. As well as the death takes ammo. This is a gameplay mechanic. Currently it is set to true, meaning if you die, if you get shot once, from what I've played, once you get shot once, you run out of ammo, which means you have to reload after you've been disabled to get the game going again. To help with the colors, there's these little variables set up to give you the color parameters. So this is green, blue, and yellow. This uses the 255 spectrum for a byte size that we'll be using later on in the color wheel. It's a pretty intense function that they have going on, particularly to create a sine wave, so it goes in and out, fades in and out, and you can see that right here. They added a few more variables for the reload game to also let you know how fast you can reload. They do have limits on it, and to track whether or not you are reloading, as well as getting your ammo to keep track of that. This is the key one later down for the LEDs to be able to modify the code, so that way you can use this ammo parameter to see how much ammo you have left. While there are a few other pin setups for the other buttons, the key one I want to bring up is this strip section. This is for the LEDs. So it tells it to begin. This is in the setup section, the void setup. So you have the begin, you have show, which is actually, it's going to tell the colors to start, and then a brightness parameter. So you can actually fluctuate the brightness. And if I remember right, this goes up to 255 as the max brightness. So 50 is actually fairly low, but definitely bright enough. In the loop, we originally just had the handle trigger and the handle IR reception. Now we've added all this section below. Update the lights, that's telling the LEDs what to do, what color to do, and what kind of pattern. It also checks for the reload button. Again, this is only for the reload code. The light code will only have the update lights section. And this reloading, again, is just whether or not you should reload and what to do when you are. Now when you press the trigger, it's gonna update the lights as well as the buzzer. This is where we see the buzzer start to come into play. So when you press your trigger, you're going to get a buzz as a reaction, and it's going to last a little bit of time, and then it goes back to low to stop the buzzing. You also have the update ammo to keep track of how much ammo that you used. This is a function that you'll see a little bit further down. Now there's a lot of extra little things that you'll find out that are basically setting up some color parameters. I wouldn't mess with them all that much. Basically it's setting what is your blue, your green, and your red colors, so that way you can see them in this color wheel spectrum. So it sets up this whole section, so that way when you're calling the red, you know what the red color that you're using are. That's what this color 2 comes from, is it set up all these colors based off of what team you're on. So team 1 is green, so team 1 uses color 1, which is the green, and so it sets up all the parameters needed for this color wheel. Essentially in this updates light, you're getting the red, green, and blue color to then give the strip which color that should be using, because you need the number from 0 to 255 for red, green, and blue to be able to create whatever color is on the strip. This is a very fancy way of doing it, and as you can see, there is a sine wave in the middle which creates a wave pattern with that. So it's a pretty complex setup to get a pretty cool look. Don't need to worry about this too much, except for one thing. There's one key thing. Since we are doing the reload ammo, you want to see how much ammo you have left in this, and the update lights doesn't do this. The ammo looks like it's supposed to in the function, but then it updates the lights in the loop, which overrides it. So I ended up actually changing this strip num pixels. That's just saying every single pixel that we have, we want to change, but we don't want to do that. We only want to change the ones that don't have ammo. So I switched this to the ammo variable, so that way it only lights up the ones that don't have ammo. And then I added a section below that basically replicated the bottom section. Let me roll down a bit. So this section here is giving the color of 0, 0, 0, or basically not on. And this is where it will actually go black or off, but we only want to do that for a certain amount of pixels. So I actually added another loop in here, a for loop, to then call what pixels are not being used or you've run out of ammo, and then change them to a different color, which is red. I added this little loop right here. Which then actually goes the inverse, so it's looking at the max ammo and then going backwards to know which ones to remove from the LED strip. And that 127.5 is a reddish, a lighter red, so it's not a crazy bright red. And this little section here now helps you see your ammo bar. So your regular color will be there, but then your ammo will start depleting and you'll see red as you are running out of ammo now. And that really pretty much wraps up all of our code for the laser tag. It was a fun learning experience, and you could check out the little video of me actually getting all of the colors working.